Okay, so you guys have gotten the start on this, but I'm just going to help you along. So we all agreed common base of 3 because 9, 27, and 81, they can all be divisible by 3. There was a good question asked, how come 9 couldn't be your base? And you have to think about, okay, could you go 9 to the power of something to get 27? No, so that's the only one that wouldn't have worked. Whereas if you looked at 81 or 9, 9 could have been a base, but the 27 is why 9 couldn't be a base. But 3 is the common base. You guys all got a great start. Our 9 can be replaced with 3 to the power of 2, which was raised to 2x plus 3. That's dividing. Okay, instead of 27, what could we write? 3. Okay, with base 3, it's 3 to the power of 3 raised to the original 3x minus 1. And that's all being multiplied by 81 to the power of x minus 1. 81 can be rewritten with base 3 to the power of 4. Good job. Raised to x minus 1. So a lot of you just distributed the exponent already, but I'm going a little slower. So we have 3 to the power of 2 times 2x is 4x, plus 2 times 3. So we have 4x plus 6. And we're dividing 3 to the power of 3 times 3x is 9x. And don't forget the 3 distributes to that back term as well, so we have minus 3. And then we're multiplying by 3 to the power of 4x minus 4. So we have the same base and we're multiplying and dividing. So when we divide, what do we do with the exponents? So we have 4x plus 6 minus 9x plus, minus 3. Okay, what do we do when we have the same base and we're multiplying? What do we do with the exponents? So we'd be adding 4x minus 4. So now we just have to evaluate. 4x minus 9x minus 5x plus another 4x is negative x. Question?
Yeah, when you divide 3 to the power of 4x plus 6 divided by 3 to the power of 9x minus 3, don't you divide the 3's too?
Where are you at? Sorry?
Like on the second step, like, yeah, right there. Like, do you divide the 3's as well, or just minus 2?
No, if you have the same base, then you're literally taking the exponents, and if you're dividing, you're subtracting the exponents.
Yep.
And if you're multiplying, you add the exponents. So I have 3 to the power of all the exponents. Okay, so starting again, 4x minus 9x plus 4x, that gives me negative 1x. 6 minus negative 3 is like 6 plus 3, so I have positive 9. 9 minus 4 is positive 5. So we have 3 to the power of negative x plus 5. Bernie, if I had y to the power of 7 divided by y to the power of 4, do I divide the y's or do I subtract the exponents? Good, so I still have y as my base.
Yeah.
7 minus 4 is 3. Okay. So even though the exponents got a little more complicated, the same rules apply. The base stays. Truthfully, in this case, it's kind of hard to do that because if I factored out the negative, then I get x minus 5, and if I flip that, I get 1 over 3 to the power of x minus 5. One of my terms will still have a negative. So it doesn't matter if you answer it like this or like this. Okay, good question. Next up, we're solving exponential equations with a common base. So the steps are listed there for you. But basically what you want to do first is make sure that you have a common base. And the rule is if you have a common base, you can set the exponents equal to each other and solve. Okay, so step 1, write each side of the equation with the same base. In part A, do we have the same base? Yes. Okay, if necessary, we use the exponent law so that each side of the equation contains only one base. Do we have that? One base, good. Okay, then we equate the exponents on each side of the equation. In other words, we set the exponents equal to each other. And then once we do that, we can solve for the variable. So we've agreed in part A, we have base 5, base 5. As soon as you have the same base, you can set the exponents equal to each other. So we're going to set 2x plus 3 equal to 7. And once we've done that, we can solve for the unknown variable. So first subtract the 3 over. And we get positive 4. Then we divide by 2. And x is equal to 2. So we're just simply solving for x. That's the goal of this. We're solving exponential equations. So anytime there's a variable, we have to solve it. Now, how can we check this? Well, let's go back to the beginning. We had 5 to the power of 2x plus 3 equals 5 to the power of 7. We solved that x equals 2. So if I sub a 2 in here, do I also get 5 to the power of 7? 4 plus 3 is 7. So you should always get that the left-hand side equals right-hand side. Okay, next up we have 7 to the power of x minus 2 is equal to 343. They're giving us the base pretty much. The base has to be 7. So can you guys help me out? 7 to the power of what gives you 343?
3.
Okay, so 7 to the power of 3 is 343. Same base, what do I do with the exponents?
Equal to each other.
Set them equal to each other. So x minus 2 equals 3. Add the 2 over and you get x equals 5. And check it out. 5 minus 2 is 3. 7 to the power of 3 is 343. So you can quickly check these. Alright, next one. Again, they're giving us the base. It's base 3. So 3 to the power of 5x minus 1 is equal to 3 to the power of what? Give me 81. 4. Good. You guys are getting the hang of it. Power of 3x. Okay. Before I can evaluate, I just need to make sure that I multiply those exponents. It's power to power law. So I have 3 to the power of 5x minus 1 equals 3 to the power of 12x. Same base. Set those exponents equal to each other. 5x minus 1 equals 12x. I love your singing. Beautiful. Okay, move the 5x over. We get negative 1 equals 7x. Then we divide the 7, and we get negative 1 over 7 equals x. Okay, have they given us the base? Base 3. Okay, on the right-hand side, we have 27 times the square root of 3. So let's start with 27. Base 3 is 3 to the power of 3. How can I rewrite the square root of 3 as an exponent?
3 to 1/3.
3 to the power of 1/2. Okay, with the square root, the denominator is half. So what do I do with these exponents? Okay, we're multiplying the same base, we add the exponents. So 3 plus 1/2 is 3.5, or 7 over 2. Okay, I'll write it as a fraction. 7 over 2. Same base, set the exponents equal. And this one was super easy. You didn't have to solve a thing. X equals 7 over 2. Felt good about that? Nice. Now to the fun bit. With exponents and logs, we're going to be dealing a lot with application questions, and this will be our first one, but it's kind of spoon-fed to you, so don't worry. Bernie, can I have you read that for us, please?
You want to read it?
Yes, please.
The bacterium triples every 6 days. The number of bacteria n present after x days is given by the formula n equals 3 to the power of x divided by 6. After how many days are there 243 bacteria?
Okay, so let's talk about what's given. They're telling us this formula. Figure out the number of bacterium after a certain number of days. They're also telling us that there's 243 bacteria. We have to figure out what is x. Okay, that's our question mark. So I'm sure some of you are taking physics. We have our formula. Let's write out what we know. They're telling us the number of bacteria is 243. What's the only other variable in that equation? X. And they're asking how many days, so that means we're trying to solve for x. So let's sub into our equation. 243 equals 3 to the power of x over 6. This question's exactly like what we just were doing. But now it's asking how many days does it take to get that much bacteria? In other words, it's asking to solve for x, and good, we have to find the same base. So what's the base? Good, we have base 3. And, sorry, 3 to the power of what gives me 243? 5. Awesome. Okay, so same base, which means I can set the exponents equal to each other. 5 equals x over 6. Multiply that 6 up. 5 times 6 is 30. So it's going to take 30 days to get 243 bacteria. Last two questions. So we have to again solve the following equations, basically solve for x, okay? So if you look at 27 and you look at 81, what's the common base? 3. You guys are getting quick at this now. So 3 to the power of 3 gave me 27, and that's raised to the power of x minus 2. Maybe what I'll do is right away, can I rewrite this as 81 to the power of negative x plus 3? Can I do that? Okay. So instead of 81, what am I going to have? 3 to the power of 4, good. Let's cross that off, don't need that anymore. And that's the power of negative x plus 3. Just do a little bit of expanding. So we have 3 to the power of 3x minus 6 on the left-hand side. Okay, just by multiplying the exponents through. And then on the right-hand side, we have 3 to the power of, imagine this is like negative 4. So negative 4 times x, negative 4x, negative 4 times 3, negative 12. Okay, 4 times negative 1 is like negative 4. So you're just distributing negative 4 through each term. From there, same base, we set the exponents equal, and we can solve. So 3x minus 6 is equal to negative 4x minus 12. Combine like terms, so I'm going to add the 4x to the left-hand side, and we get 7x.
Junior class change.
And I'm going to add the 6 over, and I get negative 6. So when I divide, I get x equals negative 6 over 7. How do we do on that? No, because that's just your final answer, what x equals. The very last question is a question you're going to have to think a little bit harder at. They're telling us basically the common base is 6 over 5. But when we look at the other fraction, we have 125 over 216. Is there something we can, or can we change 125 to base 6?
No.
But would it maybe go with the 5? Okay, what about 216? Okay, it could change to a base 6. So somehow we have to flip these. What can we do with that exponent? Okay, good. If I put the 216 in the numerator and the 125 in the denominator, the sign on the exponent just changes to positive. So if you can identify that right away, your life will be a little bit easier. Okay, 6 to the power of what gives me 216?
3.
3, okay. And 5 to the power of 3 gives me 125. So 6 over 5 to the power of 3 gave me 216 over 125. All of that is applied to the exponent x over 4, which equals my right-hand side, 6/5 to the power of 3x minus 3. So I have my same base now, and I just have to set the exponents equal to each other. 3 times x over 4 equals 3x minus 3. 3 times x over 4 is actually like 3x over 4. And that equals 3x minus 3. To get the 4 out of the denominator, I have to multiply it on both sides. So I get 3x equals 12x minus 12. Combine like terms, so subtract 3x over, and we get 9x. Add the 12 to the left-hand side, so 9x equals 12. Then I can divide by 9, and I get 12 over 9. Is that reduced? Okay, both have a common factor of 3, so if I take 3 out, I get 4/3. X equals 4/3. What do you guys think of